Hello, welcome to today's tutorial. We are continuing. Last time we ended on question 3, so today we are going to do question 4, 5, and 6. So I'm going directly into question 4, which reads, two parallel and opposite forces, each of 4,000 newtons, are applied tangentially to the upper and lower faces of a cubical metal box 25 centimeters on each side. Find the angle of shear and the displacement of the upper angle of shear of the upper surface relative to the lower surface. Shear modulus for the metal is 0.80 times 10 to the 11 pascals. Yes, I know the tone. Okay, that's the end of the question. So, looking at the question, we can pick the data from that, and the information that we've been given from the question is as follows. So I'll write data. I like collecting data because it simplifies the work. As you are working, you don't have to be peeping at the question. You can just pick on the information that you've collected. So the F that we have is equal to 4,000 newtons. 4,000 newtons. Then we have got L equal to 25 centimeters, which can be converted to meters as 0.25 meters. Then we've been told that the area, in fact, we can calculate the area because we know that area of a cube is equals to L squared, which in this case will be 0.25 squared. So 0.25 meters squared will become 0.0625 square meters. Then we were told that the shear modulus is equal to 0.8 times 10 to the power 11 pascals. Okay, so this is the information that we've been given, and I'm going to try to use this diagram as much as possible because I am very bad when it comes to drawing. But what we have is a situation where we have the force. Sorry, we have got a cuboid, something like this, and so this is what we have. And then there's a force that has been applied on this face. Okay, there's a force being applied on this face and an opposite force being applied on the other face. So we are having a 4,000 Newton force being applied and also another 4,000 newtons being applied on the other one. So once these have been pushed, there's a force being applied on this face and the other face. What happens is that this face seems to have okay, it shifts. Okay, I really okay, I'll leave it like that. But we are going to have a shift where this will seem to have moved something like this instead of it being the way it was. So as it moves, what happens is that this actually does not have any form of extension. The only thing that happens is that it seems to have shifted in terms of shape. Yes, it's like the shape changes. It was like we had lines in this manner, and then we have lines that have become something like this. Okay, so initially we had this shape on top. Okay, this is what we started with, and after applying a force, the face on top seemed to have been disfigured. it changes its shape due to the force that has been applied. So in as much as the face on top changes, the force that is at the bottom also changes, because there's this force which is being applied in the opposite direction. So the same things happen, except this one will go forward and this one will go backwards. So in the end, you're going to end up with a shape that looks a bit different from the shape that you had started with. Okay, so I'm going to go into calculating the question, or solving the question, and then we'll look at the shape again. We'll come back to this diagram, especially when we come into calculating the shear angle. Okay. So since the question has asked us to find the angle of shear and the displacement of the upper surface relative to the lower surface. So by that we mean we are talking about the displacement of this surface on top with reference to the surface at the bottom, because this will move alone and this will also move alone. That's what will happen. So we want to look for that displacement. So in terms of calculation, we calculate it like we are just calculating the extension. In actual sense, we are calculating the shear. So we use the formula dl is equal to L naught divided by I'll use E to represent shear modulus, multiplied by F divided by A. And if you look carefully at this formula, it's the same formula that we've been using all along when we were calculating the stress as well. So we are using the same formula in short. And now since we want to calculate the displacement, we are going to have to make the modulus the subject of the formula, so that it will be easier, and this will become L naught divided by change in L. Then we'll have multiplied by F divided by area. Okay, so we already have the force and the area. What we don't have is the information here. So we can go on and substitute. This will become L naught divided by change in L, multiplied by the force was given as 4,000 newtons, divided by the area, which was we calculated as 0.0625. Okay, so this is what we have. After simplification, here we're going to substitute. Sorry, I forgot. Okay, I can write this down here. Since we've been given the shear modulus, we can write it as 0.80 times 10 to the power 11 being equal to L naught divided by change in L. Then once you simplify 4,000 divided by 0.0625, you're going to end up with 64,000. Okay, that's what we have. So I want to make this the subject of the formula, and I'll have L naught dl being equal to 0.80 times 10 to the power 11 divided by 64,000. And that will give me 1,250. No, that's 1,250,000. So L naught divided by dl is equals to 1,250,000. Okay, now what I am looking for is dl. So I'm going to say dl is going to be equal to L naught divided by 1,250,000. Okay, so after simplifying, L naught is already given, so we can simply substitute, which is equal to 0.25 divided by 1,250,000. And once you simplify this value, you're going to have change in L being equal to 2.0 times 10 to the power negative 7 meters. Okay, So that's the extension that we have, the extension that we've been asked to calculate, 2.0 times 10 to the power negative 7 meters. Now, the question has also asked us to find the shear angle. So what exactly is the shear angle? The shear angle is actually going to be the angle that we are going to have, the angle that we are going to have here. If this moves the other side, we are going to have a line here. Okay. Yes, my drawing is really bad. Okay, so we'll have the angle that will be subtended at this point. That's what we are calling the shear angle. Now, because of the fact that the extension is very minimal, I know my drawing has made it look big, but the extension is very small. You look at the value that we have calculated. We've calculated 2.0 times 10 to the power negative 7 meters, which is way too small. Now, if you look at 2.0 times 10 to the power negative 7 meters, and then you also compare it to the original length of 0.25 meters. This is like way too small, meaning that they are making a very small angle in between them, the two lines. Okay, so we're going to have this something like this here, and okay, maybe this is even way too big, but we can have something that's very small. The extension sense is very small. The angle subtended is also very small. These lines are almost parallel to each other. But since the angle is very small, if we are to calculate tan theta of this angle, it is way too small that we can approximate it to just theta. Okay, so we say that tan theta is way too small. Like it is very small. Looking at the values that we have, since we know that tan theta is equal to y divided by x, right? Meaning the y value and the x values are way too different. So instead, the angle that the angle between y and x is way too small, such that we approximate it to just being equal to theta. Okay, so in short, here we are approximating. It is not necessarily equal, but we approximate it. So instead of us calculating tan theta and then calculate theta from using the formula tan inverse of theta, we're just going to go directly and calculate it in that way. Or you can even use the formula, which is, if we go back to the formulas we were using in circular motion, where we were saying that S is equal to r theta, and we said theta is equals to s divided by r. You can use that where you're going to assume that s is the extension, the little extension that we've had, and r is the L of the length of the cuboid that we have. Okay, so you can use this formula to calculate theta, where you're going to say S is equals to the L divided by L naught, which is going to be 2.0 times 10 to the power negative 7 divided, this is in meters, divided by 2.5 times 10 to the power negative 2 meters. So if you use this, you're going to find that theta will be equal to 8.0 times 10 to the power negative 7 meters. You can use this, or you can go with this where you approximate tan theta to be equal to theta, meaning that if tan theta is going to be equal to theta, then we can say that theta is simply equal to y over x. And in this case, we're talking about the L over L naught. So meaning we'll have theta being equal to, in the same situation, just like we have solved here, since we're talking about the L being equal to 2.0 times 10 to the power negative 7, and L0 being equal to 2.5 times 10 to the power negative 2. So in this way, you can solve it in either ways. You're going to end up with the same answer. Okay, so theta is approximately equal. And if you look at this angle that we have, this is like way too small. 8.0 times 10 to the power negative 7 is a very small number, and that makes sense because it's just like we had said earlier on, that these two lines are they are too close, that the angle that since the extension is very small, the lines end up being very close, such that the angle in between them is very small. Then we can go to question number 5. Question 5. So question 5 reads, let's read question 5. A glass tube is bent into a U shape and water is poured into the tube until it stands 15 centimeter high in each side. A 3 centimeter column of alcohol is slowly poured into one side. The two liquids do not mix. How far will the water column in the other side rise, given that the density of alcohol is 720 kgs per cubic meters, and that water has got a density of 1000 kgs per cubic centimeters, per cubic meters. Okay, so with the information we have, we can to go on and do our calculations. So we've been looking at the information that we have. We've been told that we have the height of water on either side is equal to 15 centimeters. 15 centimeters, which is equivalent to 0.15 meters. And if we look at it as, since we've been told that we have got a U-bent tube, and this side we have been told we have got 15 centimeters in terms of height, and this side 15 centimeters in terms of height. So meaning altogether we have a height of 30 centimeters of water. So I'm going to say H1, which is the height of water. Is it really H? Okay, I won't use H1. I'll still use H water T, which is equals to 30 centimeters, and that is equivalent to 0.3 meters. Okay, so now we've been told that a height of 3 centimeters of alcohol has been poured on the other side of the tube. Okay, now the question asks us to find the length, the how far the water column to find how far the water column in the other side will rise. So since we are having alcohol being poured on this other side, we are going to have an effect on the other side. That's what we are going to have. Now, if you go back to pressures in liquids, we know that the pressure in a liquid at any point is equal to the pressure in the same liquid at another point, meaning the pressure here is going to be the pressure there, as long as we're talking about the same liquid and it is open to the close to the atmosphere. That's what we have. So if this system is in equilibrium, then we're going to say that the pressure on this side is equal to the pressure on the other side. Okay, the pressure on the left is equal to the pressure on the right. So we'll have pressure left being equal to pressure right. So the pressure on the left, once alcohol has been poured into the U tube, what will happen is that it's going to cause this level or this column of water to actually increase, okay, because this is going to be pressing against this water on the other side. So as this is being pressed down, it's going to cause a rise on the other side, meaning it's no longer going to be 15. We do not know that value, so we can let it be equal to h. And then once this side reduces, meaning that we are going to have, since the whole column here is 30 centimeters, we can say that once this has risen up, this has reduced, we are going to have 30 minus the h, which we've subtracted here as the length of the other side. That's what we are going to have. So we're going to write the formula for pressure. Pressure on the left will be equal to, I will use it as pressure 1. Okay, pressure 1, sorry, rho. Since we're talking, we know that we are calculating pressure. So rho 1, which is the density of water in this case, since this side we only have water. So rho 1 G H will actually be equal to the pressure on the other side. Now the pressure on this other side is going to be the pressure of the water and the pressure of the alcohol. We are going to have to combine them, or we are going to add them, because they are supporting each other at some point, especially at the point where they are linking. They are going to be supporting each other. So we are going to sum the pressures this other side, and they will be equal to the pressure this other side. So we'll have summation of the pressures, which is summation of rho G, and we are going to use H. Okay, that's what we have on this other side. Now let this be H2. Okay, since H2 is going to have the height of the water and the height of the alcohol, so we'll just put it together. Then from there we'll say, since this has rho 1 G, rho 1 G H being equal to, so now when we look at the summation of the pressures, we are going to add the pressure of the water, which is going to be rho 1, okay, multiplied by G. Then the H is going to be 0.3 minus H. The reason why it is 0.3 minus H is because the total length of the water is 0.3, and the H, like I said, after it rises, it's going to rise a distance of H, and since we don't know the value of H, we won't know this value as well. But we know that if this is H, then the value this side is going to be 30 minus H. That's why I've written 0.3 minus H. The 0.3 is in meters, the 30 is in centimeters. Okay, plus, now we look at the rho of water, as in the density of water multiplied by G multiplied by the height of water. So the height of water is equal to 0.03. We've also been given. So the height is not going to change. The height of water is not going to change. It's fixed because we're using the same container. The same goes with water. The height of water is fixed. It's going to be 30. The only thing that would happen is that either it would increase on one column and reduce on the other and the like, but it is fixed as 30 unless we use a different container. So this is what we have, and I am going to expand the equation. So rho 1 GH will be equal to, so if I expand this will be 0.3 rho 1 G minus rho 1 GH, okay, plus rho 1 0.03 rho 1 G. This has 2 instead of 1, since it's a different liquid. We use 2. So I'll collect the like terms. I'll have rho 1 GH. This was negative, so it will become positive on the other side. So it will be rho 1 GH. Then it will be equal to 0.3 rho 1 G plus 0.03 rho 2 G. Okay, So once we add this, we're going to have 2 rho 1 GH being equal to 0.3 rho 1G plus 0.03 rho 2G. Okay, so that's what I have. I can divide out the G. Then what I'm going to remain with is 2 rho 1H being equal to 0.3 rho 1 plus 0.03 rho 2. So since I want to solve for H, I'm going to say H is equals to 0.3 rho 1 plus 0.03 rho 2 divided by 2 rho 1. Okay, so H will be equal to, now we can substitute 0.3. Rho 1 is equal to the density of water, which is 1000, plus 0.03 multiplied by the density of alcohol, which is 879, divided by 2 multiplied by 1000. Okay, so from here you're just putting the information on a calculator and then finding H. So once you simplify this on a calculator, you find that H will be equal to 16.32 centimeters. Okay, so now if H is equal to 16.32 centimeters, the 16.32 centimeters is actually the height, that the column height after this alcohol has been put there. And like I said, because this alcohol is going to apply pressure on top of the water, it's going to force the water level to reduce this side and increase on the other side. So the result that we have found is the water level after it has increased on the other side. So meaning, to find out how much it has risen, we are going to have to subtract 15 from this value so that we have the rise, or the difference in the rise. So we'll have the difference in rise will be equals to H minus 15, which will be equal to 16.32 minus 15, and that will give us 1.32 centimeters. Okay, so this is how much the water had risen on the other side of the column, this side. If you want to find out how much it had fallen on the other side, you're going to have to subtract H from 30 so that you get the resultant this side, which you're obviously going to get as 13.68. And from the 13.68, you would understand that it would have, in terms of height, it would have dropped by 1.32 centimeters as well. So meaning this side, it had dropped by 1.3 centimeters. This 1.3 centimeters that had dropped this side is the one that caused the rise on the other side. Okay, so that's how question 5 is supposed to be solved. Of course, you can find other means, as long as it's something that you can explain and you can account for, especially in terms of how it is coming about. Okay. So then I'm going to go straight to the last question, which is question 6, the last question for today. So I'll read question 6. Question 6 reads, a copper wire LM is fused at one end M to an iron wire MN. The copper wire has a length 0.9 meters and cross section 0.9 times 10 to the negative 6 square meters. The iron wire has length 1.4 meters and cross section 1.3 times 10 to the negative 6 square meters. The compound wire is stretched. Its total length increases by 0.01 meters. So meaning we are having different types of wires. but then we're applying one force, okay? And then collectively as a wire, which is the compound wire, it stretches by 0.01 meters. We have two wires. Same force has been applied uniformly, because from the beginning we know that if we're applying a force here, it is applied even in every particle inside this wire up to the very end. So meaning the same force is being distributed across this compound wire, and then it extends by 0.1 meters. Okay, so we want to find out now the tension applied in the compound wire, the extension of each wire, and the ratio of the extensions of the two wires. Okay. Anyway, I knew you were going to make noise, so I paused my vid.
Oh yeah, no, that's you're just simply politely asking me, go, carry your things and go.
I want to go, but then when I remember that tomorrow I'm meeting them, it's better I post the video they go through then to, oh my god. Sorry about that. So the L is going to be equal to 0.01. Oh, we have already been given 0.01 meters. So this is the information that we've been given. We are supposed to find the force. Okay, we don't know the force. Another thing that we've been given in the question is the Young modulus for the two wires. We've been given Young modulus for copper to be equal to 1.3 times 10 to the power 11 meters. Then Young modulus for iron is equal to 2.1 times 10 to the power 11. No, this is pascals, sorry. This is pascals and this is pascals. Okay, so this is the information that I collected from the question. Now we can go into solving. We are going to solve for the we're going to solve F, which is the force, and we are also going to solve the extension of each wire and also the ratio of the extensions. Okay, so how we go about this, we are going to use the formula that we've been using all along, which is dl being equal to FL divided by area multiplied by Young modulus. Okay, so now what we have here are two wires that have been combined together and have had the same extension. Okay, so meaning we are going to have the extensions of the two wires put together is what is giving us 0.01. So we need to look at the wires as a compound wire, not looking at them individually to find out the force. We are going to have to look at them as one. And to do that, we are going to split them. We're going to say dl is equal to FL copper divided by area of copper multiplied by Young modulus of copper plus F, because we applied the same force on every part of the wire, FLI divided by AI YI. Okay, so this is what we have. And with this, we can simplify or we can factor out F, where we're going to have LC divided by AC YC plus LI AI YI. So from here, we're just going to make F the subject of the formula, meaning that F, since we are supposed to calculate the force, F will be equal to dl. We're going to divide this on the other side. dl LC divided by AC YC plus LI divided by AI YI. Now we can substitute. So we have, I think it's better to use this part. We were told the extension is 0, we've been told that the extension is 0.01. divided by, so LC is 0.9 divided by AC is 0.9 times 10 to the power negative 6 multiplied by YC is 1.3 times 10 to the power 11 plus Li is 1.4 divided by 1.3, which is IC, times 10 to the power negative 6 multiplied by 2.1 times 10 to the power 11. Okay, so you put this on a calculator. I put it directly on my calculator, so you can, as you solve anyway, F will eventually simplify to 780 newtons. Okay, so that's the force that will be applied on every part of the wire, and that will give us the extension that we've been given. Okay, so now we go to part B. Part B has asked us to find, what are we looking for? Part B has asked us to find the extension of each wire. So to find the extension of each wire, we're going to use the equation for extension being equals to FL divided by AY. Since we already have the force which we've calculated, 780 multiplied by the length of the wire, which is 0.900, everything divided by the area, which is 1.3. Okay, 1.3 for y times 10 to the power 11 multiplied by 0.9 times 10 to the power negative 6. Okay, so simplifying this will lead us to 0.006 meters. Okay, and if we convert it to millimeters, we'll end up with 6 millimeters. Okay, so that's the length of the copper wire. Okay, so the L, let's put C here so that we'll have change in LC symbolizing for copper. Now, the L naught is equal to, so no, sorry, not L naught, change in L, okay, for the compound wire is equal to 0.01 meters, which is equivalent to 10 millimeters. So that's the total length, and from that we found out that 6 meters of that 6 millimeters of the 10 millimeters is the copper wire, meaning that the change in L for iron will be equal to change in L minus change in L for C, which will be equal to 10 millimeters minus 6 millimeters, and that will give us 4 millimeters. So that's the length of the iron wire. Now from there, we can easily calculate the ratio of the extensions, which is part C. Okay, so the ratio is simply just like we're dividing, we're comparing. Okay, either ways. So the ratio will be 6 millimeters to 4 millimeters. So if you divide 4 into 6, we're going to have 1.5. Of course, the units will go, and it will be to 1. So that's the ratio of the extensions. Okay, so that's all about question 6. Okay, so in the next video we'll now look at question 7 and 8. Okay, so for now that's all. I hope you are preparing so that we'll have a Zoom meeting after this.